Maybe we'll give everyone another 1 minute to get on, but we're over 50.
Let's give people a couple of minutes here.
Yeah, we're up over 50 attendees already, so they're moving quickly.
I thought that was a really interesting presentation, and we should definitely get them back to do more.
I will.
Really interested to hear their advice on text messaging and recordings during surgery.
Right. Me too. And we should review again the disclosability of our conferences, the comments at grand rounds, all those things. There are very specific rules that relate to that.
Hey, Peter, what do we do? Like, are there questions? Is there discussion at the end? How does that work in this format?
So people will be able to raise their hands to ask questions, so we can promote them to speak. Chris and I will watch the list, and then there's the QA and chat box, but we'll monitor that.
Mm-hmm.
So it's 8:05. We have 77 people on.
Okay, let's get started. So this is an exciting moment. Not every day that we get to hear Jay Mocco speak to us. Everyone knows him, but just to point out a couple of highlights. Jay is an internationally renowned individual. I don't think that I have met a single neurosurgeon anywhere in the world who doesn't know about Jay Mocco, who doesn't actually know Jay Mocco, and who doesn't admire him one way or another. You can see his titles here: Professor, Senior System Vice Chair, Director of the Vascular Center, and so on, his education and so on. They don't really tell the story of his energy and his enthusiasm. I've never met someone who is able to balance a vision with energy, drive, and productivity like Jay. He's creative. He's incredibly fun to work with for me. And I consider him a close colleague, a mentor, a friend, and someone who I admire. One of the things that I always love about presenting something about Jay is that no matter what you say, so for example, here, this slide that was recently done says that he's got more than 500 peer-reviewed publications. It's always out of date. And so this might have been made a couple of months ago, but if you were to look today, you'd see that it's more than 565. That's because every single day there's something new that's coming out that Jay has done. So it's a great pleasure to introduce him, but I also need to share my screen here because one of the funny things that you get when you pull up the web and you look at Jay is that he's all over the world and all over the internet. Of course, this picture on the top right here is my absolute favorite from University of Florida. But you just get a sense of someone who's not only deeply engaged in what he does at any particular moment, but who has interests in many, many different areas. So with that, we'll turn it over to Jay to hear his talk today.
Thank you. Thank you, boss, very much. I got to figure out, I saw one of those pictures, it had Nathan Manning photo with my name. I got to figure out how to make that happen more. He's a really good looking guy. And if that would be a plus. All right, let me share my screen. Okay, that's sharing, correct? Okay.
Yeah, we can see that.
Perfect. Figure out where to put everyone. So thank you. It's an honor to get to talk to all of you. To be honest, in typical fashion, I got an email from Alyssa asking for the title on Friday. And I thought, oh my gosh, how am I going to get this done in that time? And so I've been putting this together sort of in the hours from 12 to 2 a.m. ish. But I love when I get to do this because it gives you a chance to sort of reassess. It's like a moment. It's almost like a moment of mindfulness where you kind of focus in where am I, what have I been doing, and where are things, and what's meaningful to you right now. What have you been thinking about? And so that's what I'm going to try to share with you guys. I'll go over some facts and things, but really I'm hoping to give you some insight into kind of what makes, on some level, me tick. I think a lot of our CV team tick, and hopefully give you some lessons that might be worthwhile to take away. It's not clicking. Oh, there. Briefly, these are my disclosures. The PI on a bunch of trials, of which I'll talk about pretty much all of them. I don't think I referenced Phil, and I have invested in or consulted with a bunch of companies. Don't think I talk about any of them in this talk. And I was recently made a contact PI for a StrokeNet U01 grant, currently unfunded, but we'll be resubmitting in the fall. And I will talk about that and the connections to that. So to talk about CV problems and using research to figure those things out, I thought I'd start at the beginning, which for me is, sorry, I'm having major problems here. Maybe if I move my keyboard here. Which for me kind of is third year med school. So by way of background, I went to University of Miami. We didn't have a lot of means as my family. So I got a college work study, and I got a job with the chairman of neurology. Totally random. Like, I didn't pick it. It just got assigned. I might have been checking people into the gym or working in the admissions office. It's just what I got assigned. And it was neat. The guy was neat. It was fun to go over to the medical school. But I was doing research with him. He had me counting nuclei on dorsal root ganglion. And I finished that experience thinking I hated research deeply, and I didn't want to ever do anything in the area of research. I was like, I just want to take care of patients, be very clinical. And I got to third year in medical school. And I hope many of you had the same experience, but as you're walking around and as you're taking care of patients, there's so many, I started asking questions. Well, what about this? Why don't we do it this way? Could we do this? I was blown away that why is this not there? There's so many questions that we don't have the answers to. And most of the time, the answer was, well, we don't really know, or this is where we go. And it blew my mind. And it was really exciting to me that there was so many things that we really don't know about medicine. I think the average patient really doesn't get how much of this is either habit or just what someone before us did, or sort of anecdotal practice. And that was very inspiring for me. And then that actually led me to seek out to do research with Sandra Connolly, who you see there on your left, and eventually to partner with Nick Hopkins. And I put them up as two extremely formative mentors for me in those early years, because they're the same type of people. They're the type of people that you can't spend an hour with either one of them. You can't spend 10 minutes with either one of them where they're not positing a question or wondering about how something could be done differently. And it was a great blueprint for where I wanted to go and what I wanted to do. And in fact, it led to this kind of an example. And I want to put this in as an example. My very first publication that I ever wrote, I went to a journal club. It was Stefan Mayer was running an ICU journal club, and they reviewed a paper on the use of enoxaparin in neurosurgical patients. And in the review, there were all these meaningful and appropriate critiques about the methodology and where should this lead and what should happen next. And then afterwards, everyone got up and just left the meeting. And I went to Sandra and I said, should you want me to write up what we were all talking about and see where that goes? And he said, sure. And so my first paper ever was a correspondence in the New England Journal, the first thing I ever wrote. I was like, man, this is easy. It took me 20 years to get back into the New England Journal. But it was the fact that he would say, yeah, medical student, go, let's figure this out. Let's write these questions and tackle it. I think that that's important. And I think if we can bring that kind of inquisitiveness every day to our practice of medicine, then it's hard not to want to do research. It's hard not to want to answer these questions. Every day in life, we're presented with the opportunity to learn something new or to try something different. And that's a message I really took away from both of those mentors, and still sort of reinforces my life. There's a quote I recently came across from Einstein: creativity is seeing what others see and thinking what no one else ever thought. And I love that quote. And it reminded me, actually, so if medical students are on and are watching, if we're in the room, I'd look at you. But I would say, when you go out and you interview and you go around the country, you get to meet all these successful neurosurgeons, famous in neurosurgery terms, and ask them questions. And I remember asking Charlie Wilson what his advice would be, or what sort of helped him be the impactful person he was in neurosurgery. And he said essentially this quote. In fact, I wonder now if he was paraphrasing, but he basically said, you go through your day, you take care of your patients. He's like, keep your eyes open and look around. Everyone's doing everything, and there's stuff right there to see that needs to be evaluated and seen more clearly, but everyone's just going by it and not addressing it. And so, taking hints from people like Einstein or Dr. Wilson is key. I would also turn to another luminary intellectual that I think very highly of, Ted Lasso. And for any of you that haven't seen that show, I'd recommend it, although it's relatively vulgar, but it's fantastic. And he had a quote. He actually, interestingly, in the show, it incorrectly attributed it to Walt Whitman, but it's not actually a Walt Whitman quote. But it was, be curious, not judgmental. And he's talking about his experiences in life and how people would judge him and give him problems. And he said, they thought they had everything figured out, so they just judged everything. They just went through life saying, that's good, that's bad. But if they were curious, they would have asked questions. They would have tried to figure those things out. And that's important. It's important to not think you have it all figured out and to want to answer those questions. And that's fundamental to the way I approach these things. And so, to give an example of that, early in my career, I had the chance to moderate at the CV section, moderate a session. And in that section, there was a little discussion was beginning about whether or not you should use these fatter, thicker diameter coils to treat aneurysms versus traditional thinner coils that were felt to be safer. And so there was a little bit of discussion about this. I realized that there was some discussion going on. So I posed a question to the audience. I said, how many people think that if you put in these larger diameter coils, you're going to get better outcomes, reduce your recanalization? And about 80% of the crowd raised their hands. And at the time, someone who I knew who he was very famous, but I didn't personally know, said, it makes sense. If you build a house with a stronger frame, it'll last longer. Interestingly, that person was Alex Berenstein, who I may be on this talk, but is certainly someone I count a real friend now. So it's interesting how these things go, but I'll never forget him saying it in his accent from the audience. But so that's great, right? It's great, but everyone walks away from that meeting and they just say, wow, that was a fun discussion. I learned something. The question is can you do more than that? Can you try to figure it out more? And so I started looking at the evidence and I said, what do we have? And the answer is there really wasn't meaningful data. I'm not going to go through sort of the heart of the data, but this was a large retrospective study of over 200 patients that looked at a slightly larger diameter coil, 0.02 of an inch thicker, but they had a 6.5% reduction in recanalization. So, it's retrospective, it's not great quality, but it certainly looked promising. And there's another one study that's similar that was looking at GDC 18 versus GDC 10 coils. And again, they saw about a 6% higher packing density and about a 3.3% or 50% relative reduction in recanalization. And one of the most interesting papers was an animal study. The purpose of the paper, and this is about digging into the literature, the purpose of the paper was to look at coils with little fibers on them versus coils that don't have little fibers. And but if you looked at the data, what you realized was whether or not they had fibers or not, if you had the fatter coils, you had much better occlusion later versus the skinny coils. So they weren't really looking at that. They were looking at whether there was a fiber or not, but it made a difference. interesting side note as well, this is 2008 when this paper came out. I'm a fellow. When I researched it, it was probably 2009 or 10, just started my career. The author, Quil Turk, I didn't know who he was at all at the time. He's become one of my closest friends in the field and really a very important figure in my life. So you've got all this anecdotal evidence. What can you do? There's no high quality evidence. And so that led me, well, I'm on a quote kick, so I decided to write this one too, from Hippocrates: "Science is the father of knowledge, but opinion breeds ignorance." So again, don't be judgmental, be curious. Don't feel like you know the answer, but see if you can figure out. And so that led us to come up with FEAT, Framing 18 Coils in Cerebral Aneurysms Trial. And I really wanted to highlight this as a starting point of this discussion of wanting to do research, because sometimes when I've mentored people over the years and I've talked about doing research in partnership with industry, they have a judgmental approach to it, to be frank, where they say, well, that's all BS, or I don't want to just create marketing data for some company, or any number of variations on that. But I want to implore to all of the faculty that might be interested in doing something this, particularly the younger guys starting out, and girls. I don't know if I'm allowed to say guys and girls, the younger people coming out, that you can do really meaningful science in this context. And so you don't have to just do a marketing study for a company. And I think that this is an example of doing that. I'll never forget, I made a proposal, turned it in, we went back and forth a bunch, and I actually hashed out the final details of the funding with the president of the division while on the line for Snow White at Disney World with my kids. It was a really long line, and we were sitting there, and he called, and we spent about 10 minutes finalizing that. But what we came up with was real science, a prospective randomized trial to evaluate angio stability in the larger versus the smaller coils. Now, what's the win for the company? Well, we're only going to use one coil in the trial. That's important scientifically. You don't want to have a lot of variables, right? In the scientific experiment, you keep everything stable, and then you change one variable and you see the influence of that. So it's good for the science. Frankly, it's also good for the company, because now anyone who's interested in this question and who participates in this trial is going to be using their product. So, you can be realistic about the potential benefits on both sides, but you can still be committed to doing meaningful science. And so that's what we did. And interestingly, again, not just shooting from the hip, but being really thoughtful, we decided to target mid-sized aneurysms, because it turns out there was another randomized trial that was published just before this. And what they discovered was that with the really small coils, there was no difference between the types of coils. It was a different variance in coils, but basically everything worked really well for the really small aneurysms, and nothing worked very well for the really large aneurysms. But the mid-sized aneurysms, in that cohort, they actually saw benefit with their study. And so I thought it made a lot of sense for us to target exactly that population, right? You don't treat, it's like doing an aneurysm trial for subarachnoid hemorrhage. You don't want to treat all the grade 4s and 5s because there's such a high rate of poor outcomes. You don't want to treat all the 1s and 2s because there's so many that do well. You really want to target that sweet spot of the 3s where you could potentially really affect their outcomes. And actually, I'm really excited to say that just near the end of last year, we completed enrollment. So this was a 10-year labor of love from inception to making it happen. But we're now waiting for the final follow-up pictures, 1-year outcomes of the final outcomes. But we have a 651 patient prospective randomized trial. That's the largest prospective randomized trial for where everyone got aneurysm treatment that we have in this context. And so, or the field has. So this is exciting. We're going to get some meaningful answers, and we're going to have this massive data set where we can analyze, like, for instance, we are capturing other pieces of information. Did you intend to stent? Did you intend to balloon? Did you actually stent? Did you actually balloon? All these other questions, aneurysm dimensions, everything's core lab adjudicated. This is going to inform aneurysm care for many years to come, which personally I find exciting. So a second question, or actually really a judgmental statement that someone shared for me, There's a well-known neurosurgeon interventionalist who is relatively conservative in the way they like to approach things. And this person, not here at Sinai or ever here, this person said to me, you can't coil small aneurysms, it's too high risk. If you try to put coils into a little aneurysm, it's going to pop. All those patients have to be sent to surgery. You guys, I think, know anecdotally, believe that that's not the case. But this is a perfect example where the person didn't want to wonder about it, didn't want to figure it out. They just said, I'm not going to do those. I'm going to refer those all. So that instead, we became curious when we designed a trial called Coils, the coiling of aneurysms smaller than 5 millimeters. It's single arm, but it's all core lab adjudicated. It's all prospective. And we've enrolled 300 patients in that trial. In fact, we've just got the last imaging follow-up on the last ones. And the next few months, we'll be finalizing that data and putting that out there. If you're keeping track, that's now 1,000 patients with independent, high quality prospective core lab adjudicated data that we've collected across these two trials just in the last number of years. And Coast took, because it was single arm, and it didn't take nearly as long as I think we finished Coast in 4 years. But there are obviously so many more questions for us to address, right? There are people that say, well, I'm going to follow the guidelines. And if you're outside the guidelines, then you're wrong, right? Or there are going to be people that say, well, I know what's best for my patients, even though it's outside the guidelines, I'm going to treat this. And where this is a very hot topic right now is in stroke thrombectomy, right? Who should we treat? And currently the lay of the land is defined by the American Heart and Stroke Association written guidelines. And if you look at those, this is the statement on thrombectomy and who should be treated. There's a couple of interesting things about this statement. One is it says patients should receive mechanical thrombectomy with a stent retriever if they meet the following criteria. I think that's a real problem. They later say direct aspiration thrombectomy is recommended as not inferior to stent retrievers. So I don't understand why they even continue to pull them apart. It's like arguing whether you wear Nike cleats or Adidas cleats makes a difference in how well you play soccer or something to that effect. So I would strike out calling out any particular technology since it's been proven. I'm happy to say, by the way, that was another situation where being curious was helpful. That guy, Quill Turk, that I mentioned before, that did the aneurysm trial, he called me up one day and said, hey, I was going to do a stent retriever pull with a aspiration catheter behind it, but I couldn't get blood back from the aspiration catheter. So I pulled it out and the clot was in the end of it and the blood vessel was wide open. He's like, you got to try this. And I said, that sounds ridiculous. But I was like, all right, I'll try it. And I did it and it worked. And so we did a few more and it worked more. And that started the whole ADAPT or aspiration for thrombectomy, aspiration thrombectomy. That curiosity, we did a whole bunch of papers. We put it together. We wrote it up as a case series. We then did a multi-center case series. And then we went, and again, meaningful science out of partnership with industry. We went to a company that made aspiration catheters and we asked them to fund us to do a high quality, completely independent prospective randomized trial. The company never saw the data till the night before I presented it at the International Stroke Conference. They just gave us the money to the tune of $12 million. And we ran this trial. That trial has changed the way thrombectomy is done. Almost everyone does aspiration now as a first-line therapy. We published the results in Lancet and it was meaningful. And so again, having that curiosity and looking to find ways to answer that curiosity, whether from independent funding or from a partnership with industry or NIH or DARPA, whatever you pursue, it's worth doing. But this is the current recommendations. You need to have a pre-stroke MRS score of 0 to 1, basically have no disability at all, not even minor. You need to have ICA or M1 occlusion. You need to have a high NIH stroke scale. You need to have a high aspect scale. Aspects means that you have very little infarct to start with. And so let's like evaluate this. Let's think about this, right? So you start with the first one, pre-stroke MRS. So what does that mean? So for those of you that aren't familiar with the MRS 0 means you have no symptoms, nothing that bothers you in your life that way. 1 means you have some symptoms, but it doesn't affect you at all. 2 means you have some disability, but you're not dependent in any way. You can do everything independently. 3 means you can still walk around, but you need some help somewhere. Now, 3 is a big range. It could be a very minor dependency. Someone needs to cut your steak for you, or you can't do, you're older and you're not, you functional and you live independent, but you can't really manage your bills anymore. Your daughter helps you with your bills or something like that. So there's a big range. So this is effectively saying that unless you're exactly perfect, you shouldn't get a thrombectomy. And obviously that's a problem, right? And people are addressing this and working on it. Here's a paper where looked at populations across 2 centers that had pre-stroke disability and evaluated how they did. And it turns out patients did pretty well comparing the patients that had no disability to the patients that did. In fact, 26% of, if you had no disability, you went from 26% good outcome without treatment to 36% with good treatment. And when you looked at it in comparison of MRS 0 to 2 or 3 people with some disability, they had equal benefit. They still benefited in that context. However, what was interesting was they did have a much higher mortality. And this has been shown in a lot of studies now. So if you have pre-existing disability, we can almost certainly, you're going to have a better outcome if we do, well, over the course of a population, there will be better outcomes with thrombectomy relative to no thrombectomy, but the mortality rate is very high in that population as compared to the modified Rankin 0 to 1 population. Anyways, that's not important. There's anterior circulations. So they do have a follow-up caveat in those recommendations that the benefits are uncertain, but it may be reasonable to consider treating patients with an MRS greater than 1. But the truth is we need data. And so being curious, we're working on that. I'm co-PI, a dual PI with Eva Mystery on a grant called TESTED for the treatment of endovascular intervention for stroke patients with existing disability. And we're going through the PCORI process right now to get that funding. This is a kind of exactly what PCORI is looking for in terms of population evaluation care. So hopefully that will come through. One of the other things they say is if you don't have a high NIH stroke scale, if you're generally functionally okay, you shouldn't get an intervention, right? But the truth is about 30 to 50% of acute ischemic stroke are people with minor symptoms. So that's, I don't know, 300,000-400,000 people per year. Still, almost a quarter of those patients that come with minor stroke symptoms end up with really poor outcomes, right? And the most critical component is early neurologic deterioration, where they come in, they have a minor stroke, and then all of a sudden they go south, they get much worse. And it turns out that happens somewhere around a quarter to almost a half of patients, right? And if that happens, your outcome is much, much worse. It's almost 60% worse. Turns out for patients that come in with minor stroke symptoms that have a large vessel occlusion observed, then they're at over 2-fold increase of having one of those early neurologic deteriorations. And it usually happens within the first 24 hours, 5 to 16 hours after showing up. Now, here's the problem though. If you come in with a minor stroke, 2/3 of them don't even get pictures. So we don't even often know if they have that large vessel occlusion, right? People estimate that it's probably on the order of 70,000 people per year in the US that have minor stroke symptoms with a large vessel occlusion that present in the US. Think about that. That's a big number. That's double the number of ruptured aneurysms that we see in the United States, right? What's sort of at the heart of neurosurgical cerebrovascular care. If you have a minor stroke system with an LVO, you have a 7 times increased likelihood of poor outcome compared to if you don't have an LVO, okay? And somewhere between 1/3 to a half of the patients end up having a poor outcome that come in with a minor stroke. About 40% say. So it's not all of them. 60% of them without treatment end up doing okay, but 40% do really poorly. That's an issue, right? What do we do about that? Now, we don't have great data on this because most of the trials, both in Hermes as well as the ones that we participated in and Thrace, they excluded patients with low NIH because they wanted to be able to make sure they could show a benefit. But for the data we have, it's not significant, but it suggests a almost 2-fold benefit to doing thrombectomy in that patient population. I'm not going to dig through all of these different studies here, but basically these are all people that have looked at exactly this question, looking at low NIH patients. And this though is worth taking a few seconds on this graph, because what it shows is if you look at the patients that have proximal versus distal occlusions, you see a real effect. So if they have a low NIH stroke scale with a proximal occlusion, there's a very, very powerful benefit. If they have a low NIH stroke scale, but it's a distal occlusion, you don't see the same benefit. So again, being curious, looking at the different populations, saying, how can we provide benefit? This is just some more data, but it's debated. JAMA Neurology had a paper published of over 250 patients where they found no benefit doing thrombectomy in that patient population, right? So maybe it's not a good idea to take these patients and attempt to reach them and attempt to treat them. Now, one of the things that we do is we say, well, let's wait. Let's bring them in with a low NIH stroke scale. And then if they get worse in the ICU, we'll take them. That's obviously fraught with some concerns. I think all of us have had the patient who deteriorated overnight, but it wasn't picked up till rounds and such. But ideally, that could be a good idea. But it turns out that if you do delayed rescue, there was a paper that suggested that instead of having a 30% good outcome, if you had to go to rescue, it went down to 75%. So we know early neurologic deterioration is associated with poor outcome. We know that if you do thrombectomy, it prevents the likelihood of having an early neurologic deterioration. We also know that early treatment is better than delayed treatment, rescue treatment. But we also know that when you do intervention, it carries a risk, right? Up to 12% risk of bleeding. So is it possible to identify those patients that are going to do worse versus those that won't? Can we find the 40% of patients that have low NIH stroke scales and LVOs that are going to end up doing very poorly? And can we treat them? Or the alternative is we get thrombectomy to be so safe that it makes more sense mathematically to just treat everyone. Don't try to find the specific population, but treat as many people as you can that have this presentation. And that's currently debated. This is a publication in AJNR that argued exactly for that point in terms of safety. But the reality is the current recommendation is that it may be reasonable to consider in this patient population, and we need that data. And we're working on that. So here we are participating in and running a trial called LVO Champs. Hazem's a PI for that. And we're also participating in a trial called ENDOLO, both of which look at this population. And so we're working to get those answers. But we're not chasing trials. The trials become self-evident when you're curious about these questions. And another one of the recommendations that they exclude are people with large strokes, large cores. If you have a severe stroke already on your CAT scan, does it make sense to return blood flow? Well, turns out there's data that suggests that we probably should. This is a study that was published in NIHSS that suggested value in that patient population. Here's another publication out of France, out of their endovascular registry, which showed, now this is a little tricky. What they said is if you have a low aspects and we treat you, if we get your blood vessel open, you do better than if we don't. So that's different than comparing to medical arm. But this is a lot of the way the early stroke trials were done. And it's really kind of a proof of concept that there is potential value to opening the blood vessels. This is a further paper out of the same French registry that basically demonstrated 4.5-fold improvement in good outcomes. And then this is from the SELECT group. This is run by Greg Albers, which likewise, if you see, they took patients that were modified Reagan 0 to 2 that had big strokes on their first CT, and they had over double the number of patients that achieved independence back to 0 to 2 afterwards versus those that did not. So we need better trials. We need RCTs to figure this stuff out, right? There are big systemic meta-analyses that do this. Again, all of them suggest a benefit. So even though the brain's dead, restoring blood flow helps recovery, helps new pathways develop, helps other ways to make it done. But we need more studies to figure it out. We need data. Currently, we just have this loose suggestion that it may be reasonable to consider in this population. We're studying this. So we have a trial here at Mount Sinai called LASER, low aspect stroke endovascular reperfusion, where we're enrolling patients, randomizing them to figure out, does it make sense to treat this patient population? It's funny though, we still run against judgmentalism versus being curious. We've had cases where The physician said, well, it's a young person. I don't want to not offer them treatment. So we really have to do this. And they don't offer the trial. That's dangerous. I think you have to make an honest assessment of whether science provides equipoise. And if it does, you have to commit to that equipoise completely and wholeheartedly. So one last one around the stroke side is the guidelines say, unless it's in the M1 or the ICA, you shouldn't do the thrombectomy. But the truth is the field's already moved out to distal vessels and medium vessels. And in fact, one of the questions is, what is even a distal vessel? If you look at the literature that's out there right now for M2 occlusions, both independent series like this one published by Max Moken and his group, or even the efficacy of M2 treatment in the Hermes collaboration. So this is 5 prospective randomized trial with individual patient level data pooled. There's clear benefit for the treatment of M2s. So an M2 should no longer be considered a distal vessel or a questionable treatment. This data is pretty robust. An M2 occlusion, you see an odds ratio of over 2 for better outcome with a p-value of 0.03 in the Hermes collaborative data set. And in fact, this gets worked out and proven no matter how you chop it up. If you say, where exactly is the M2? Is it a dominant M2? Is it a non-dominant M2? They all show benefit. So that's pretty clear. And so when you look at these papers looking at distal occlusions, you got to see how much of them are M2s or how many are really distal. For instance, this paper, you can see there's only 10% are really truly distal. Everything else is M2s. But in this cohort, they saw tremendous good outcomes and improvements. There's now a literature developing around exactly this question. How far out do we go? There are people who are curious that are driving this. This is a little retrospective review that suggested benefit. You can see the clots in very distal locations, PCAs, distal ACA, distal MCA, but they were able to get good reperfusions, very low complication rates, and reasonably good outcomes. This is something to keep in mind, right? If we can do it safely, should we be trying to figure out the best way to do it? Here's a little example of a case here. I think this was Sharam's case, but you can see this is quite distal, but this patient had a profound aphasia. And so he was able to go out with the wire. I think this is playing, yeah, bring a little microcatheter out to that distal location, right? We're like at M4, 5 somewhere, right angular branch, and then use that aspiration catheter to restore the blood flow. You can see that the arteries completely opened up there. And the patient had near complete resolution of the aphasia and resolution of the hemiplegia. So it's reasonable, but we need to figure it out better. We need better data to understand that. All of these things, medium vessel occlusions, low NIHSS circular, large core, these are what we call indication expansions. So the question becomes, do we have to do, one thing you might be curious about is, do we have to keep doing these one-off trials, or can we create an infrastructure by which we can do all of these studies? And so we're working on that. So there's a thing called StrokeNet Thrombectomy Endovascular Platform, or STEP, which I'm fortunate enough to be able to be a part of as a PI, a multi-PI with Jeff Saver and Pooja Khatri and a couple other leaders in stroke field. And we're working with the NIHSS now. It's interesting. It's so different as a platform that it's not a typical council study section type process, but there's sort of a separate outside funding process through an RFA that we're having weekly meetings for a few hours, structuring this, working with the people at the NIH that are experts in platform trials. So for those of you who don't know, platform trials have revolutionized cancer therapies and other things. So the idea is you create a master protocol and platform where you're collecting data on every patient that gets treated with a given, for instance, patients with brain, GBMs, or patients with breast cancer, or whatever it is. You're collecting all that information, and then you layer in specific types of trials within that whole population. And patients may get randomized into multiple branches of those various treatments. You pull that data to get to an answer. And the first step of that is going to be StepStone, which is all these indication expansion questions. And so hopefully that'll come online by the end of this year. Where else is our knowledge lacking? I mean, pretty much everywhere, particularly ICH. Everyone here is familiar with the amazing work Chris has done, really typifying and codifying the technology or the technique of scuba using endoscopic ICH evacuation. Now that's exciting. We've refined a technique that I truly believe is transformational and important. But is that really enough? And the answer isn't. You need to be curious and do research. And so we're doing a lot of it. We just completed enrollment in INVEST, which is a prospective single-arm trial of endoscopic evacuation. Chris and I have partnered with some colleagues of ours, a guy by the name of Bruce Campbell in Australia, and have supported their starting a randomized trial there called Evacuate. Chris is running a trial here in the US, a prospective randomized trial called MIRROR, evaluating a particular type of surgiscope, a particular type of endoscope called a surgiscope. And MINUTE, which I'll highlight briefly, is a large prospective randomized NIH trial that we got extremely favorable scores on last round. And we're submitting again in this next cycle to look at early evacuation, less than 12 hours with endoscope scuba technique for ICH treatment. It's 231 patients randomized 3-to-1 treatment versus control arm. It's a phase 2 futility design. And we have forced recruitment, just like the IV TPA trials that were done in the 90s. We have forced recruitment so that 2/3 of the patients are get to the OR within less than 8 hours. So we're going to be able to first answer, is it beneficial within less than 12? If that group shows futility, if we're not able to refute futility, then we're going to look at it in the less than 8 hour group. So it's a pretty neat experience, a pretty neat trial, and hopefully we'll get that funding before the end of the year. There's a rich history of evidence-based care in vascular neurosurgery, right? We have 7 prospective randomized trials for thrombectomy. I was lucky enough to be the PI on therapy, and our group contribute to that. 3 prospective randomized trials for 12 to 24 hour thrombectomy. We were major contributors, we were lead enrollers for positive, and I was able to be the PI for that study. 3 ongoing prospective RCTs for MMA MeVo. Chris Kellner's driving one of those, membrane, which you guys may have heard of and we're treating here. Please, any of you that have patients with subdurals that don't need to urgently go to the OR, or even if they do, touch base with our team and touch base with Chris in that capacity. The field is replete with high quality evidence generation. And I'm really proud that our group is leading in that charge. And there's tons more, right? STEP and tested and laser and LVO champs, things I talked about, but also Insight, a clotomic study that Chris is running. MINUTE, I talked about MIST, that Joanna's really, it's hard to imagine the level of national and international conversation around mobile stroke thrombectomy that Joanna's caused and driven with her work in MIST, and obviously aspiration thrombectomy with Compass. There's many more things going on. But I would counsel that all of these are related to aneurysms and strokes and embolizations. And this is, again, let's be curious. I think we're thinking too small. This is a saying that I've gotten from Dr. Betterson, not stop thinking small, but don't think small. Because there's so many bigger things to go. I would highlight interventional cardiology. The very first angioplasty of a cardiac artery was performed in 1977. By the 80s, cardiac percutaneous coronary intervention or balloon angioplasty was rampant. By the 90s, stents have become the standard of care, and they're putting stents. For about 25 years or so, 20 years, that's what interventional cardiology was. It was going in and using a balloon to open up a blocked artery. That was it. But if you look at interventional cardiology these days, they replace valves, right? They have what's called structural heart. They perforate or close atrial septums. They put plugs into atrial appendages, right? Or they rewire the heart. They put in electric leads to read and or stimulate. They ablate the circuitry of the heart, right? So they're doing all these different things, structural, electrophysiological. Why can't we be doing those same things? And I think we will. Many of you may know Carl Heimland. He's the chair at Tufts and a friend of mine, a really great guy. He worked with his endovascular partner, Adel Malik. And they've developed a transvascular shunt to replace VP shunts. Basically, they go into the petrosal sinus and create a new arachnoid granulation, a tube that perforates into the CSF space and allows the CSF to drain into the jugular. They've done it in 4 patients in South America with very promising results. It might not be long with just like the cardiologists, structurally change the anatomy. we might be doing that in cerebrovascular and endovascular. Likewise, a very hot topic is the venous system and the drainage process. Do we restructure? Do we open up closed transverse sinuses? Pierre Gabin, who's been really a revolutionary in terms of driving future therapies, is running the River Stent trial, which is completed enrollment. They don't have all their follow-up yet, but they've got all their patients enrolled for venous sinus stenting for IIH, right? There's a whole structural component to reworking the anatomy. And what about electrophysiology, right? Here, you guys are a little more familiar than other places, but we're doing that too, right? Tom Oxley's leading the charge with Synchron, transvascular brain-computer interface, both recording and stimulating. It won't be long until we're doing all of these things. I think that cerebrovascular neurosurgery, if we remain curious, the future is going to be much, much bigger than the past. And that gets me pretty darn excited. I think in general for neurosurgery, for each of you in each of your fields, the future is wide open. If you maintain that curiosity and you want to go after those questions, there's so much you can do. And I'm happy to say that much of it's being led by the younger generation. There's a picture at the Senior Society right in the front. We've got Sinai, our Sinai team with Chris Kellner and Justin Massatelli. So I'm very excited about it. Thank you for taking the time to listen to me, and happy to take any questions.
Thank you, Jay. That was inspiring. Beautiful. Any comments, questions? I think people are blown away.
Hey, Jay, Costa.
Yep.
Awesome talk, man. Really inspiring, and thank you for giving that to us. The things that I've appreciated with what you've done and others is you've taken an area in neurosurgery to another level, first of all. But number two, you've kept it under the auspice leadership of neurosurgery. So where am I going with this? How many times do we talk about areas in neurosurgery we've lost, right? We've lost other specialties. We haven't led them correctly. We published outcome studies. And, I think what today in your Grand Rounds talk is that, with management of stroke and other cerebrovascular disorders, and then other ideas and concepts to take it to the next level, that leading the charge. And I think, that's an important concept that I'd love to, briefly speak about.
I'm sorry, I just don't know if I totally get it. So you're saying in terms of leading the charge as a neurosurgical community?
Yeah, I just, some of these areas in neurosurgery in terms of management of stroke have always been non-neurosurgery, right? And now, neurosurgery is kind of neat in this whole new area.
I think, so I have two thoughts on that, okay? The first one is, go back to Ted Lasso. I think one of the biggest problems with neurosurgeons is we're too damn judgmental. That's my honest opinion. I think that as a field, we tend to say, it was one of my real bugaboos. We go around and say, oh, this is the way it's done. This is the way it should be. This is the only, oh, Stitch showed you can't treat ICH, can't do that. No, now every patient's going to not be treated and just die. Like it's judgmentalism versus saying, well, okay, look, don't just go crazy land, but in a rigorous way, let's start answering questions and figuring it out. And you're right. Look, there's no question my career has benefited in that I was actually giving this advice to somebody last night. It's worth looking for the areas where there are real questions, even if everyone in your field says, oh, that's not neurosurgical. I remember early in my career, I got made fun of for, clot chaser, like why are you pursuing, stroke, that's not neurosurgical, it is. And you know what? Nick used to tell me stories about when he started his career, he'd get up to give a talk at AANS, and the front row, all the senior neurosurgery guys took out newspapers and opened them and read them on purpose, to insult him as he was, giving his talk that it was not neurosurgery. I had a very famous chairman who's retired now in New York, literally laugh about how endovascular wasn't neurosurgery when I was looking at what I wanted to do for my careers. So part of it is not being judgmental and looking into those areas and like thinking about what you can do. Look what Doug Kanzioka's done pursuing radiosurgery, right? Or Isabel, you know, there's so many people that have done like tremendous things. You know, it's just it's very easy to just think, oh, I'm going to make fun of that, or I'm not going to be interested in that, or you know, carry those sort of judgmental glasses on. And I think if we can shed them, I think it's important. And then the other part of my answer, I said I had two parts, is I think the world could use us. I think neurosurgeons, as a general rule, have a great work ethic, are intense. We're well situated to do these sorts of projects and research. Because what we do clinically generates good revenue, we're not like worried that we're going to get fired if we don't have our next grant to support our salary, as is often the case for medical specialty researchers. I think we're really well positioned to do some of the most exploratory and creative work that exists. And so I think it should be done, and we should bring it to the rest of the world. And many of my closest friends are not neurosurgeons that have the same attitude. They're doing the same things, radiologists, neurologists. I think there's room for everyone as long as we're all curious enough and working to make it better.
Thank you, Jay. I think in addition to reaching out to other fields, the ICH program has exemplified that, because all of us of a certain age were raised nihilistically about ICH. It's just really nothing there to do. And by asking the questions that you've asked and focusing everything in one location, and then convincing a talented young person to join you with this, I think you're making progress in what is now a neurosurgical disease that we really had given up on. So it's very inspirational, and also it looks like a lot of fun, right? It's not just hard
Really?
work. It's a blast.
It really is. I read a quote, and I'm not going to remember who said it right now, but I read a quote about someone like talking about being in the lab and researching something and figuring something out. And when they figure that thing out and you get your results, you're the only person in the world that knows that. It's pretty cool. Like you've contributed, you're going to contribute a piece of knowledge that's going to change how things are done in some level. And that's what I feel about the clinical research. Like when we first run the first numbers, we lock the data set and you run the numbers and you get those back and you say, holy crap, aspiration really works. This is awesome. And you know it's going to impact lots of lives, way more than you could ever touch with your own hands. It's really fun. So.
Any other comments or questions from the group? All right, thank you. That was wonderful.
We do have a few questions in the Q&A
Okay.
box. Sorry about that. Just pulling them up late. We have
LDO. I think he meant LVO.
he actually wrote. Okay, I see. You
I
already
think I answered
You already
that.
answered that one. It says, "What's the quick screen in the office for a patient who you suspect might have a large vessel occlusion and minimal neurologic signs?" CTA is the answer there. And then we've got a longer question here.
It's about following up on research. Maybe send an email if you can, and we can do that offline.
Yep, exactly. Okay, I see. And then a comment. All right.
All right, guys.
All right, thanks, everyone.
Thanks, everybody.